So for the second video over these notes, we're going to concentrate on the entropy portion of these notes. So let's flip a couple of pages back to where we discuss entropy. Now remember, entropy is the other factor that determines whether a reaction is going to actually work or not. Along with enthalpy, entropy will determine whether that reaction is spontaneous. Now entropy is defined as the amount of disorder in a system, both in energy and positional microstates. So the sloppier it is. So microstates is kind of like, I guess, a way of thinking about what kind of state it is it in. Is it more ordered? Is it sloppy? So it can be very energetic, and high energy is going to give us a more disordered system, and lots of different positions. A high positional microstate is going to give us a great amount of disorder. So this S, okay, yes, it does not stand for sloppiness. It actually is a German word, but it does stand for our disorder. I think of it as sloppiness. It just helps me, used to help me remember it. The second law of thermodynamics states that everything in the universe moves towards a greater state of disorder. Reactions are entropically favored when the products have a higher state of entropy than the reactants, meaning we want the products to be sloppier. We want them to have a greater state of disorder. Now, what do we mean by a greater state of disorder? In chemical reactions, the highest state of disorder is a gas. So the entropy of a gas is higher than the entropy of a liquid, which is even higher than the entropy of a solid. A gas has more energy and it has more positional microstates. There are more disorder. When you have a solid, there are fewer energy and positional microstates. There's less disorder. Entropy also increases when the substance is divided into parts. The more parts or particles, the greater the entropy. I think of kids. If you have 1 or 2 kids, you have a lower state of disorder than if you have 15. So the greater the number of particles, the greater the entropy. So we're looking at a high entropy being a gas. A gas has high entropy. We're looking at more parts and an increase in temperature. It's also going to give us a higher entropy. So one of the things they're always asking us on the AP test is to decide, looking at a particular reaction, whether the entropy is increasing or decreasing. Remember, if you have an increase in entropy, an entropy increase means you're getting more disordered. If you have an entropy decrease, then you're getting more order to the system, less disorder. So let's look at this first example. We've got copper as a solid turning into copper as a liquid. Now when we look back up at our examples, we see that the entropy of a gas is higher than the entropy of a liquid, which is also higher than the entropy of a solid. So if we're dealing with a solid here, that's the lowest entropy we have because it's more ordered. Turning it into a liquid is going to make it start moving around. It's going to have more disorder. So it looks like in this case, changing from a solid to a liquid is going to increase our disorder, increase our entropy. Taking magnesium carbonate, which is a solid, and turning it into products that, first of all, we go from 1 particle to 2 particles. One of them is a solid still, so that doesn't help anything, but one of them is a gas. So once again, it looks like we increase our disorder by getting more particles and by getting a gaseous state, which is by far more disorderly than a solid would be. Finally, on the last one, aqueous When you have ions dissolved in an aqueous solution, that means that they're moving around, that they're flowing around with that water, and it's going to be much more disordered than having solid precipitate of barium sulfate. So since we have more disorder on the left, looks like we're decreasing in entropy, decreasing in our state of disorder. But if you look at the cartoons that are also on your paper, look at those real quick and just think about why they make sense now. Because one of the funniest things about being in chemistry is that you get geekier and geekier jokes. This entropy seminar, if you'll look at what it says, the results of a 5-year study into the second law of Thran, it gets worse and worse and worse, because it's going into a greater and greater state of disorder. That's what the second law of thermodynamics says. Our department of entropy over here on the right is incredibly disordered. I have a high state of entropy on my desk. I have a high state of entropy in my closets at home. I could put a department of entropy sign up on those as well, but that's the interpretation of that particular cartoon as well.